examples of calculating limits. We'll work through them one at a time. We want to find the limit as x approaches 9 of root x minus 3 over x minus 9. So our first strategy is just to see if we can substitute straight in. And if we've got x equals 9, put that in there, we're going to get divisibility by 0. So the denominator is 0. In fact, the numerator is going to be 0 as well. So we've got to actually think of what else we can do. And on first looking at this, it doesn't look as though we can factorise, but yes, we can. Root x is, if we square root x, we get x. So we can say that's equal to the limit as x approaches 9. The numerator stays the same. Now, x minus 9 can be written as root x squared minus 3 squared. So when you square root x, you get x, and we've got 3 squared is equal to 9. Now this is the pattern which some of you may remember as dots, and dots stands for the difference of 2 squares. It is one you should remember right through this course and others, and the difference of 2 squares says that a squared minus b squared is equal to a minus b, a plus b. So it can be factorised. So the difference of 2 squares. So here we've got the difference of 2 squares, something squared minus something squared, so we can use this pattern to factorise. We keep writing limit until we actually do the substitution in. Top line, once again, has not changed. The numerator, the denominator though, now instead of something squared minus something squared, we can go root x minus 3 times root x plus 3. So difference of 2 squares there. That allows us to now do cancellation. And so we've got the limit as x approaches 9 of 1 over root x plus 3. So we're just left with that down there now. So some of you will go straight from here to the answer. Now we can substitute in, we won't get a 0 top or bottom. So we can go x is equal to approaches 9, we've got the square root of 9 is 3 plus another 3, so that'll be 1 over 3 plus 3, which is 1 over 6. So the limit as x approaches 9 of root x minus 3 over x minus 9 is equal to 1 on 6. Okay, so that's the first one. The first type is x approaches a. The other one is x approaches infinity. Now, straight substitution is not going to work here. So we need another strategy, and the strategy I talked about was taking out the highest power of x that's common in the numerator and the denominator. Well, the highest common one is x to the power of 3. So we write limit x approaches infinity. We keep writing that until we substitute in infinity. Now we're going to factorise and take out x. The highest power is x to the power of 3. Will be common to top and bottom. And what have we got to multiply x cubed by to get 2x cubed? Well, that'll be 2, and then the plus. What have we got to multiply x cubed by to get 5x? Well, that'll be 5 over x squared. And when you multiply that out, you'll get 5x minus 7 over x cubed. Go down to the denominator now. That'll be 3 minus 4 over x. When I multiply x cubed by 4 over x, I'll get 4x squared plus 1 over x cubed. Now, what we can do is say, righto, as x approaches infinity, now before we do that, these will cancel, and we get 1 and 1, so we're just left with that over that. Now when we put x approaches infinity, 5 over infinity squared is going to be 0. 7 over infinity cubed is going to be 0. So we get 2. Now we drop writing limit when we put it in and do the substitution. 2 plus 5 over that will be 0 minus 0 all over 3 minus 0 plus 0, and that'll be equal to 2 over 3. Alright, now that will do for those two examples.